got the parent function, x squared, and we have the general form, a parentheses x minus h close parentheses squared plus k. Here our function is the square, squaring x. You'll notice that h operates on x before the function is applied. So then h is our horizontal translation. K operates on the output. That is, it operates after the function x squared, the square, is applied. So it's going to shift us up and down, up and down. And then a, again, is for absolute value. We can say a is the slope on the right-hand side. It's a little more involved with quadratics, right? Because quadratics don't have a constant slope. Okay, but I'll get into that in a minute. So here we have a function, j of x equals x squared minus 3. This minus 3. What is this minus 3? Is it the h or is it the k? If you think about it, you can say to yourself, well, is the 3 happening before or after the function is being applied? Well, I take x and I square it first. So I've just applied the function. And now I have minus 3. Well, that means that the minus 3 has to be k. Okay, because it's happening after the function is being applied. Okay, if you think it logically, then you don't have to worry about memorizing the general form. You don't get any formulas on the final exam. So you just have to, if you have a general sense of what's going on, then you don't have to memorize what the general form looks like. Then h has to be 0, because there's nothing going on before the square is being applied. And then a is 1. I don't see a number in front of the x squared, so that invisible number in multiplication is always 1. Now, we talked about, before we even, look at this, we just take the vertex of 0, 0. Okay, remember, in absolute value, the vertex was 0, 0. Well, guess what? The parent function for x squared, the vertex is 0, 0. What happens to this 0, 0 if I subtract 3? Okay, so I had 0. I square it. I get 0. But then I subtract 3. So now I'm at 0, negative 3. Well, what just happened? That vertex has been moved down 3. So the transformation is a shift down 3. If we tie that just by looking at the value of k, we know this k is negative. Well, where are the negative values of y? They're down. So that's the down part. And then the value of k, negative 3, the negative is down, and the 3 is how far down we need to go. Okay. Now, as for the rest of the graph, you can pretty much guarantee that this is going to be a non-calculator part. So the question is, how can I graph a quadratic function without a calculator? Okay. You can use a table of values. Okay. X, and then y, and then we might do, say, negative 2, negative 1, 0, 1, and 2. Okay. Negative 2 squared is 4, minus 3 is 1. Negative 1 squared is positive 1, minus 3 is negative 2. Negative 3, negative 2, 1. And we can graph those. 0, 3, 1, negative 2, 1, and negative 2, 1. Okay, and we draw ourselves a nice curve here. That's our quadratic function. Now, with a little practice, and I have to practice this a lot before I teach it, I get a general sense for what a quadratic function is going to look like. We know that it's going to have a parabola shape. And one of the things I do is I look at, okay, well, I take x and I square it. So if I start at the vertex, and it's very important that I'm starting at the vertex, and I move 1 in the x direction, the y direction moves the square of that, so 1 and 1. And that's how I would get my next point. Then I go back to the vertex, and I say, well, if I move 2 in the x direction, I need to move how far in the y direction? Well, 2 squared. 1, 2, 1, 2, 3, 4. And then that's how I get my graph. So if you think about it like that, you can actually graph a quadratic function rather quickly. Say, okay, if I moved 1 in the x direction, square it, and that's how far I moved in the y direction. Okay, now what about this minus 3? Well, if I started at the origin, then I'd have to apply the minus 3. But since I know all my points are shifted down 3, I just don't worry about it. I just start at the vertex, 1, 1, great. 2, square 2 is 4. If I move 3, then I have to move up the square of 3, which is 9, and that would give me my next point. Okay. Now, it took me a while to wrap my head around that, so you may want to stick to the table in the interim, but if you think about it, it'll come to you and you'll realize, oh, I can graph these rather quickly. Okay. Here we have x squared minus 2. This minus 2, what's going on with it? Now, I take x and I square it first. Nothing happens to x before I square it, which means h has to be 0. And then I subtract 2, which means k is negative 2. And there's nothing else going on, a is 1. So this is going to be a shift down, because k is negative, 2. Okay, now remember my parent function had a vertex of 0, 0. So if I shift that vertex down 2, my due vertex is 0, negative 2. And I can plot that. What about the rest of the graph? Well, I can make a table, or I can say, well, change in x of 1, change in y is 1 squared. And there's a mirror image on the other side. The change of x is 2. The change in y is 2 squared. 1, 2, 3, 4. Mirror image on the other side. And then we can graph that. And there you have it. Okay, now there's one thing we forgot. Anybody remember? We need to say where the mirror is. The mirror, the axis of symmetry, is actually x equals 0. Now we haven't actually moved the graph off of the y axis in terms of its axis of symmetry, and it's very difficult to put a dashed line over a really dark line already. So here, in this case, we might want to just say the axis of symmetry is x equals 0. Okay? Or you can fake it, put a dashed line kind of to the side. And that's actually my preference because writing the words axis of symmetry actually takes some time to do. It's a lot faster just put a dashed line right next to the solid line. And I just indicate that the see how I'm kind of doing it to the side here? So it's obvious to the person grading my paper that I know what I'm doing. And I'll just say x equals 0. Okay, and then on this one here, we can do our axis of symmetry again is x equals 0. Oops, I want to do that in red. Okay. Notice in all these cases, when we're talking about the axis of symmetry, that it's always x equals, because it's a vertical line. But this value 0 corresponds to the value of h. The value 0 corresponds to the value of h. Okay? So then here, once we know h, we technically know the vertex, the x-coordinate of the vertex, as well as the equation for the axis of symmetry. So it's all really tied in together. Okay, and after we do these examples, we'll kind of formalize this in some statements. Okay, this next one here, a is 1. Okay, I take x and I square it. There's nothing happening to x before I square it, so h is 0. And then after I square, the function is applied. There's a plus 4 here. that might mean k is 4. That's going to be a shift up 4, right? This k is our vertical translation. Vertical translation. So let's plot the vertex. Okay, 0, 4. And now we start with the vertex because it's very important that you get the vertex right. If the vertex is wrong, the rest of your graph is going to be wrong too. So we're going to get that correct. And then, what's the rest of the graph look like? Well, it's a square. So if I move 1 in the x direction, I need to move the square of 1 in the y direction. If I move 2 in the x direction, I need to move the square of 2 in the y direction. 1, 2, 3, 4. Okay. And then we can draw it. And then put in the axis of symmetry. Here x equals 0. Okay, so that is horizontal translations, and we visualize that with the absolute value function, as well as vertical translations, and we visualize that with the quadratic function. Okay, let's turn to the back of our paper. And here, rather than drawing, and rather than given the function and then having to draw it, you're given the drawing, we need the transformation, and we need to know the actual function itself. Okay. It's the absolute value. Okay, let's start with the vertex. The coordinates of this vertex, just do it here, vertex. The coordinates of that vertex is negative 2, 0. Okay. We know that the parent function has a vertex of 0, 0. So how did we get to negative 2, 0 from 0, 0? Well, we had to go left 2. Well, that's the transformation. Shift left 2. If we shifted left 2, that must mean that h is negative 2, because that's a shift left. H is left and right, horizontal. Shift left of 2. Okay. The slope is 1, 1, so that means a is 1. And then k, there's no shift up or down, so k has to be 0. So now we can write the function, now that we know the a, h, and k. So we can write g of x, it doesn't really matter what letter you use here, equals, okay, a is 1. You can write 1 here if you want to, but for what, right? X minus. Now, the general function has the x minus, so I always start with that. Then I look at the value of h. H is negative 2. So that second negative sign makes it plus, and then the 2. Close the absolute value sign. There's nothing going on after the function is applied. There's no shift up or down. So that's it. I'm done.